Remember last week when I introduced that chat thing to you guys? There's already been several extra credit opportunities on there, so if you're not on that, you probably should get on that. Remember, the website is slack.cuw. It's what? cuwcs.slack.com. So just by visiting here, you'll be able to sign up and download the apps for your phones. And
if you keep logged in, you just go to slack.com and automatically brings you.
Yeah, and there's apps for your phones, so you just get a push notification whenever there's something new posted.
Unless you turn them off.
Well, don't turn them off, because there's already been some extra credit opportunities for like free quizzes and stuff like that, just for showing up to, like yesterday we had the first senior seminar presentations. So they were yesterday. They're gonna be Thursday at 2:35, next Tuesday at 2:35, next Thursday at 2:35, and I think the following Tuesday at 2:35 in this room. Those are our seniors giving their like kind of final presentation before we dump them out into the world. So you get extra credit for every one of those events you show up to, and then you paste into Slack saying you were there, blah, 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 that stuff. So I'd encourage you all to sign up. We're also doing some other announcements in there, but there are some Slack-only extra credit opportunities. So if you're not on Slack, you're missing out on some opportunities.
Did you put that on that 200 page?
Well, I'll probably put it out on general, because it's for all my classes, rather than post it 10 times. I don't remember if I did general or CS announcements. Yeah.
It's in general, because nobody posts, not everybody even CS announcements yet.
But in any case, I would check on that if you like getting extra points in classes. It's a good thing. Plus, it's my way of pressuring your other professors in computer science to also give you extra credit. I don't know if they will or not, but you never know. Okay. So, homework assignment. We were creating this thing called build formula. Okay? And where was I writing build? Okay, here's build formula right here. Okay, so our idea here is that initially we were just building a quick formula that just generated one random number followed by a plus sign followed by another random number. And just to quickly, here we are printing out input, so we'll just run this real quick. So we'll see that the math it generated was 25 plus 432. Then it shows us we got the answer right. We just hard-coded it a 5. That's interesting. Oh, I think we were doing it at the very end just to prove that we can just have a single value, right? Let's see. So we want to pass in input. $335 plus 783 is 1,118. If I run it multiple times, I'll get different versions of those functions because my build formula is always generating it based on a random number. All right, but we were supposed to write build formula so that it built kind of a random length formula. I know some people did it for just a formula with 10 elements in it. That's fine. It's the same exact logic. I don't remember what I asked you to do, but it's the same crap. All right, so when we think about that, I don't have a keynote open here. Our simplest formula is just a number, right? So 513 would be a simple formula that we proved could work last time. Kind of the next layer up would be a number followed by a plus sign followed by another number. Next layer up might be a number followed by a plus sign followed by a number followed by a plus sign followed by another number. So on and so forth, right? So if we start breaking this down into what we're looking at here, this is a left operand, or a single number. All of these guys have a single first number, followed by 0 or more plus signs followed by numbers. Here's a plus sign followed by a number. Here's another plus sign followed by a number. All right, so it's that plus sign followed by a number part that we need to concatenate multiple times. Make sense? All right, so what we're going to do is we're going to kind of do this in little pieces. So I'll just actually, we'll actually use the other version. I'll steal one of these. Didn't we? Oh, so close to pitching that. Oh, it's got to be the left guy. Oh.
It's weird that they put it there and it's that easy.
Just totally dangerous. All right. I think, didn't we stumble upon last time that there's a formula for just a generate a random number between two things? Yeah, random integer from 1 to 100. So we can even steal that if we want. But let's just keep using our cool kids one that we wrote last time. All right, so for starters, what we're going to do inside of build formula is we want to go through and let's just generate 10 numbers. Start off with that. Okay, so we want to do something some number of times. So we're going to go ahead and create a loop. We'll throw this guy in here. And actually, just for the sake of argument, let's just do it 3 times. So I only have to hit the OK button 3 times instead of 10 times. Okay, and each time through, let's go ahead and just print out a random number. So we're going to print something. What are we going to print? A random number. All right, and for right now, I'll just not do any math. So here's my actual program down here. All these guys are just untapped resources. These are just functions that we've written. So functions are reusable chunks of code. We write once, can call them as many times as we want. If we never call upon this guy, he never gets used. Just like right now, our program just sets input equal to whatever build formula returns, which is nothing. And then it prints out whatever input was. So right now we're actually, this won't print out anything. This won't be equal to anything. This function just goes through and prints out 3 things. These other functions we wrote up here, like our do math and our string to int, these guys aren't being called. They're just untapped resources right now. So we'll go ahead and run this, and we see there's our 716, there's our 430, and there's our 310, and then we get undefined because that's what was actually returned by build formula for right now. I didn't actually return a value, and that's what got printed. Okay, so we're printing out 3 random numbers. All right, well now what I want to do is I actually want to print out 3 plus signs followed by random numbers. Just like we talked about over here. Besides this initial number, all we're doing is we're generating a plus sign followed by a random number. A plus sign followed by a random number. A plus sign followed by a random number. Those are the things that we're doing multiple times to build up our formula. Okay? So, how do I put together a plus sign and a random number? How do I build that? So I want to print out 3 plus signs followed by random numbers. Go ahead.
Well, print and then
I need to build some text, right?
create text.
Create text, this guy?
Yeah.
All right, and the text I'm going to be creating, what's the first element? Plus sign. Second element is our number. All right, now I'm going to print out that. So this is building a string that's a plus sign followed by a random number. We'll do 3 of these. Plus sign 296, plus sign 580, plus sign 283. Okay, now, and there's my undefined thing. Now I want to get multiple plus sign random numbers following each other. So instead of printing it 3 times, what I want to do is I want to build up a string with plus sign random number, plus sign random number, plus sign random number. So I want to build up a string that has 3 of those plus sign random numbers in it. Okay, so I need to do string concatenation. How do we do string concatenation in Blockly? We use this append dude, right? Okay, so we're going to need this guy. And to get the ball rolling, we're going to need to go ahead and create a variable. So we'll use our variable s here. We probably use that someplace else, but that's okay. And then what we're going to do is we're going to start this guy off as the empty string. And then each time through our loop here, we're going to set s equal to, we're appending onto s, the string that we created right here. All right. Then in the end, let's go ahead and return. I'll just steal this real quick and drop down to s. We're going to go ahead and return s. So we'll start s off as the empty string and then keep concatenating stuff onto it, in this case 3 times, ultimately returning s. Down here, what are we doing? We're storing inside input whatever build formula returns, which should be, in our case now, plus sign number, plus sign number, plus sign number, and then printing that out. So there's our plus 731, plus 255, plus 511. We're building up our solution one little tiny step at a time. Okay, now I want to do this a random number of times instead of 3 times. Okay, so let's do a random, out of curiosity in the assignment, did I say 10 times or I say up to 10 times? 10 times, that's fine. So 10 times, we'll do this. Now we have 10 times. Okay? But we are missing one number at the very beginning. Correct? So we have all of our plus sign number, plus sign number, plus sign number. We need to, at the very least, generate an initial number. Okay, we're going to do that. I'll actually just steal this line here real quick. We'll put it right here, and we're going to append onto our text a number. So these 2 lines right here just give us an initial string containing a single random number between 1 and 1,000. That's all it does. And then we tack on a whole bunch of plus numbers after that. So in this case, it'll be exactly 10 of those plus numbers after that. So there's, I guess, what would have been the solution to the homework? Or actually, the solution to homework probably said do a total of 10, so you would have just done this 9 times. But anywhere, anything like this is fine. Okay, so we can get a big math formula, and then in the end, we can print out so we'll print out the formula, then we'll print out the do math, passing it input, showing that it can do that math for us. So there's the formula, and there's the solution of all those numbers added together. Okay? Now, if we want this to happen a random number of times instead of 9 times in this case, let's go ahead and we'll get rid of the 9 there, and we'll use our other version of the generating the random number. So we'll use this guy. So we'll say a random integer between 1 and 10. We can actually, let's say, between 0 and 10. So we may not add any additional things. We might not even do a plus anything. We might just have our original number, which we proved last time that that would work. Okay? So this is going to generate a formula with at least one number in it. That is the original number that we created up here with these 2 lines, followed by between 0 and 10 additional numbers. Okay, so there's a formula there. Run that. Let's run it again. Shorter formula. Longer. All right, so we're seeing we're getting some different length values. You know, we can certainly do this if we want to really go crazy with this. We can say do this up to 100 times. There's our formula. There's our answer. Just out of curiosity, just steal this number real quick. Let's force it to 100. Ran pretty fast. 10,000. Boom. Yeah, works. Let's see at what point it gets slow. 100,000. Just dot, dot, dot. Works for that. Million? Maximum execution iterations exceeded. All right, so we can't add a million numbers together. Get rid of this, go back to our random guy here. We'll leave it that, 1 to 100. So this lets us generate some fairly random numbers. All right, so that was roughly the homework. Questions about that, how we kind of built that up one step at a time. For those of you who struggle with this, you really need to come over here and draw these pictures. What's the formula look like? What's a formula look like? What's a formula look like? And then try to identify the pattern there. And the pattern's going to tell us the problem we actually have to solve. In every one of these cases, we had to generate this very first number. And then we added one or more. You know, I guess for our homework, you added 9 additional plus signs followed by 122s. So you initially had to figure out, how do I make something that looks like that? Then how do I glue multiples of those guys together? And then how do I glue the entire thing together the right number of times? Okay, see how we just broke that down? All right. Scroll down here, actually, just for right now. Let me steal this XML. We'll just put it somewhere. Let's paste it in here. Let's save this as CSC200 XML. Good enough. All right. So we're going to shift gears just a little bit during class today and then kind of shift back to this for our homework assignment. We want to create a little quiz game. And we're going to start off with a guess my number game. So we want the machine to come up with a random number. We'll start off between 1 and 10. And then we're going to get up to 3 guesses. Well, initially, let's just give ourselves an infinite number of guesses. Every time we guess, it's either going to tell us if we got it right or whether we're too high or too low. Make sense? So giving us some interactivity between our things. So I'll go ahead and let's empty out, just delete our program here. I'll leave all those functions up there though. Okay, so the first thing we need to do is we need to generate a random number. Easy enough. So we're going to create a variable. We'll rename this guy. Let's call it the number. And we're going to set this guy equal to a random number between 1 and 10 initially. Okay. Now, we want to let the user, before we go any deeper, let's let the user take a single guess. Single guess at the answer. All right. So we're going to, I think it's under text. Can we prompt the user? Yep. Do we got to print that? Oh, we can guess either a number or a text, so we'll ask them for a number. Oh, we need to store it somewhere. I get it. We're not printing it. All right, so what is your... Here. Please enter a number between 1 and 10. Okay, something like that. Disconnect this guy real quick on here. And we're going to go ahead and set guess equal to this guess. Okay? And then just to prove that we did in fact read stuff in, let's just go ahead and print our guess out. We'll print our guess, and we'll print our number as well. There's guess. And then here's the number. Is that what we called it? Yep, the number. All right, so we'll randomly generate a single number. Now notice we're not doing this inside of a function yet. We're just, this is our program. Our program says a procedural approach. Do this, then this, then this, then this. All of this crap up here is currently not being utilized. Okay? So we'll generate a random number between 1 and 10, store it in the number. Then we'll prompt the user to enter their guess. We'll store whatever they type in guess. Then we'll print out their guess, print out the number. Kind of proving we have all the building blocks we need to work with. All right. Please enter your guess. So let's say 4. All right, so our guess was 4. Here's what we printed out, and let's see what the actual number was, 6. Okay. Now, we need to now look at what their guess was and determine whether or not it was too high, too low, or correct. Okay, so we need to ask a question. Correct? So let's just add that piece. So they've made their guess, we've generated our number, now we need to ask our question comparing their guess to the actual number. All right, so we're going to go into our logic. If guess is equal to the number, if we got it right, then what are we going to do? Let's print out winner. Something like that, right? So we'll go into text. We'll say, well, actually, don't I already have some prints? Here we go. I got a print right here. We'll print out the text winner. All right. Now we need to add an else. Else if our guess is less than our number, let's print out too low. Otherwise, our guess must be too high. So we'll throw an else in there. That's the only other possibility. Okay, generate a number, read in our guess, give them some feedback as to where their guess is on the spectrum. Did you get it right? Was it too high? Was it too low? And then in the end, let's just, so we don't go insane, let's go ahead and print out what our number was so we can test to make sure it's giving us accurate feedback. So after that conditional there, we're going to go ahead and print out what the actual number was, the number. Okay. What's our guess? We got a guess? 6. Too low. And now we should find out what the actual number is. I'm going to say it was 7. I almost said 8. I only had 9 things to choose from. All right. All right. So now we want them to be able to continue to guess until they finally get it right. So we're going to do something more than one time. Should start screaming a loop to us. Okay. Now, do you see how we're building this up in little steps? This is what you should be doing when you're working on your homework assignment. Okay. If you're already past this and this makes you can sit down and just write this yourself, great. You're ahead of the curve. All right. But for most of you, this is difficult for you. So solve it in little tiny steps like this. Generate a number. Ask for a guess. Prove you got both of those guys. Now compare your guess to the number. Now let's do that multiple times until you finally get it right. So we need a loop. Initially, let's just create a loop that lets them get 3 guesses. Okay? Keep it simple, and then we'll see if we'll kind of look at the differences between our loops. So we're going to repeat something. And let's just give them 3 stabs at this. Okay? We're only going to generate this number one time, correct? So we do not want to generate our number inside the loop. But we do want to let them guess each time through the loop and then figure out what how their guess was compared to the actual number. Right? Okay, so this stuff up here, not in a loop, but this stuff goes in our loop. So generate the number one time, then we'll let them make 3 guesses. Each time through this loop, guess, then we're going to ask the question comparing their guess to the actual number. All right, what's our guess? Bubbles?
3.
Peer pressure.
9.
Okay, so go 3. Too low. Next guess, Pebbles. 7. Oh, hold on. It didn't prompt me yet, did it? Oh, yeah, we're cheating. We're cheating. We are cheating. Cancel. Stop. At least we only did it 3 times, right? All right. There. All right. Pebbles, we're playing for your game here. What's your first guess? 7? Remember, this is a new number. So you don't know that 3 is too low at this point. You're good? You're good with 7. All right. Too high. Next.
4.
Too low.
5. 6.
I wouldn't buy the 7.
How did you lose at this game?
That's
Here, just to prove that we can actually have a winner.
Can you win it in 3?
Well, can I win it in 3?
Yeah.
Oh, obviously, I wrote the code.
You split it in half.
Clearly, I'm the developer of this awesome game. I can beat it in 3.
You can win it in 3 no matter what.
Too high.
5. Do it again.
All right. Just I need to hit cancel on this one. Just to prove to you, I'll actually win it on the first try this time. Okay? Just to show that what are the odds? 1 in 10, actually. I'm glad that was recorded. First take, people. All right. So now, instead of giving them 3 tries, we want to let them keep guessing until they finally get it. Okay? So we want to continue to go until they finally get it. So let's look at our other loops. This loop only lets us do something some number of times. Okay? But we have some other loops to choose from. We have a loop that allows us to repeat while something is true. Let's look at this one. We can repeat until something is true. And what do we want to repeat until? What must be true for us to stop repeating?
Yes.
This guy is equal to that guy, right? Guess is the same as the number. That's what must be true. Now, an issue we have here is, let's just take all this stuff and let's put it inside that loop. Put this loop back up here. Does guess even exist initially? Let's see how this guy treats it. Okay, so it pretends like guess doesn't have anything in it. So that this actually will work. So we'll say 3, too low. Let's say 5, too low. Let's say 7, too low. Let's say 9. Oh, it was 10. Oh, whoa, whoa, whoa. Whoa.
9.5.
Well, you don't have any equalization for picking out the winner.
Oh, this guy up here. Yeah, our if statement's now broken. So we really want to print winner afterwards, right? You stuck in an infinite loop? You're going to really wish you had copied your XML. My worlds are colliding. All right. So we'll set our number. We're going to repeat until guess is equal to the number. This works because the behind-the-scenes language here, JavaScript, is a loosely typed language. So we're allowed to use a variable before we filled it with anything. From a logic perspective, I would do this. I'm going to, up here right after number, I'm going to set guess equal to -1. All right? It worked before, but it worked before because of kind of a caveat of the language. Now we're saying we know for a fact that guess, which starts at -1, will not be the same as one of our numbers between 1 and 10. These guys cannot be equal to each other the first time through. So we're guaranteed to execute the body of this loop once. Okay? So now, repeat until guess is equal to the number. We'll prompt for a guess. Ask if the guess was less than the number. If it was, we'll say too low. Otherwise, we'll say too high. But wait a minute. It might not be too high. They may have won. Correct? They may have won this game. Let's do this. So let's throw an else if back in here. Else if it's too high, print out too high. Else, we could choose if we wanted to not do anything. But we know that we'll say winner, but then we're going to stop asking. Because after we finally do guess correctly, we're going to spin back up right here and ask, is guess equal to the number? And it will be. So the code will end. Go ahead and hit play. So let's do 4. I'm just too good at this. All right. What are the chances of it being 4 2 times in a row? It's just terrible. 3 times in a row? Can it be 4 3 times in a row? All right, we have to have broken code. Here, let's just put an 8. If we win on this one, or oh, wait a minute. I did just get it 3 times in a row. 6. Too low.
7.
All right. So now it's letting us play. So let's go with 4 again. Oh, at least that was 3, 1. I wanted to make sure we could test our logic out there. Okay. I'm kind of pushing my luck. Should I just win on the first try again?
Try. That's scary.
I'm just saying, but this may have actually been a Christian worldview. I said a little prayer right before I did it, and sure enough, kept winning. You missed it. I got the right answer 4 times in a row. First shot. I answered so well that we questioned whether our code was broken.
Exactly.
1 in 10,000 chance that you get that right.
Yeah, there is. That's true.
It's like ridiculous.
Do it between 1 and 20.
I could do it between 1 and 1,000 and still get it right the first try. Am I pushing my luck here?
Just a little bit.
Okay, if I get this right.
You should believe we all felt
All right. So I just did that with my little prayer.
It still says, please enter a number between 1 and 10.
Yeah, that's okay. I know the prompt is incorrect.
You can use that.
Oh, I shrunk.
You're abusing your power.
So my energy's low. Oh my gosh, we're going to be in trouble this time.
Why are you still asking for a number from 1?
Well, I just didn't change the text. Okay, so 7 too high, 760 too high, 755.
752. 754. Ooh.
750. Not too shabby. Okay, so we have a little game. Now what we want to do is, at this point, our game is just sitting. This is our main method, if you will. When we run this, it just runs. We want to actually put this code inside of a function. So again, I kind of want to drill home this idea of functions. So we're going to do something here. We're going to name this play guessing game. We're going to take all of that crap and throw it inside of play guessing game. Now, when I hit play here, what's going to happen? Nothing happens. Because right now my program doesn't do anything. I just took all that logic we just wrote and I put it inside of a function. This doesn't get called unless I actually call that function. All right, so I'd have to come down here, go into functions, play guessing game, and now it'll run. Oh, this is still going to 1,000, isn't it?
You can get it in 3. That's it. 27.
Right. Winner. Okay.
Might want to change that number.
So,
100. Change it to 100. Oh.
okay, so we'll do it to 100, and let's update our text so we're prompting them correctly. All right, and now what we want to do is we want to keep score. We want to keep track of how many guesses it took them. All right, so every single time we make a guess, we need to keep track of, we need to have a counter for the number of guesses, right? And so we need to store something somewhere. What kind of animal do we use to store things? Well, I need to store just one value, a number.
Okay.
Variable. This goes back to like week 1 of class when we talked about the 3 ways human beings solve problems. Memory, asking questions, repetition. Notice how we're using those 3 things over and over and over again here to solve these problems. I'm remembering something. I'm remembering something. I'm repeating something. I'm asking some questions. We're solving all these problems in terms of those 3 things. That's what's in our toolbox. And we're just doing it Blockley's way. So now I'm going to go ahead and give myself another variable. We'll call this guy num guesses. And we'll start num guesses off at 0 because we haven't had any guesses yet. Every single time we get a guess, we prompt them for a guess. Immediately following that, we should add 1 to our guesses. So we're going to set our num guesses variable equal to 1 greater than it currently is. Play the same game we've been playing all along. In the end, let's print out number of guesses. One in 100, let's go 50. Too low. Let's do 70, too low. Let's do 90, too high. Let's do 80, too high. 75, too low. 77, too low. 79, 78. Winner. Took me 8 guesses. Okay. Not too bad. 8 guesses, not too bad. All right. So questions about any of this stuff? Kind of make sense what we did? So I'll steal this as our starting point. For your homework, go ahead and generate a formula. Show the user the formula. The user then has to do the math and make a guess at the answer. We then calculate the answer by running it through our, what we call it, do math. And then we say correct if they get it right, incorrect if they get it wrong. Make sense? They get 10 questions. Keep score and give them a percentage at the end. I just explained lots of little tiny pieces, and I'll put it in Angel. Okay? Start off by letting them guess once. See if they got the right answer. Okay? Then let them guess multiple times, maybe up to 3 times. Count how many of them they got right. Then do it up to 10 times. And in the end, since you know it was 10 times, the number they got right, out of 10, display that as a percentage correct. Kind of like you're grading their quiz. Make sense?
So we don't want to tell them like too high or too low then?
I guess I would say just give them one shot.
Okay.
I mean, here's a math problem. Do the math. I mean, you guys can use a calculator, but I would probably test it so you get it wrong sometimes. But give them one shot at it. Here's a math problem. It's right or wrong. Okay? If they get it right, add 1 to their score. If they get it wrong, don't add 1. In the end, give them a grade. Make sense? Okay, I'll give you this as a starting point. Again, solve this in little tiny steps. Everything you need, we have in here. Okay? I'll see everybody on Friday.
Yes.